Hey boys and girls, we're going to talk about Turing Tumble. This is for 4th grade. Mr. Wojcik here. This is my 3rd time trying to record this, so we're having a little technical difficulties here, so we'll give it another try. Turing Tumble is actually a computer. It can help you count, add, subtract, divide, multiply, or make patterns. Those are some of the more complicated things that it can do. We'll start out with very basic activities, and it'll get a little harder as we move forward. Turing Tumble, again, is actually a computer. Computers can be very big, but we also have some other smaller computers like laptops, Chromebooks, iPads, and phones. The inside of the computer has lots of stuff or parts that support the computer, just like this picture here. All of these parts support the central processing unit right here, the computer. And this is the main part of the computer that makes the computer seem like it's smart. That's very small. And if you have an iPhone or a cell phone or a laptop or an iPad, that central processing unit is even smaller than this. So it's a device that what makes the computer do all of its really smart things that we tell it to do. So computers are not really that smart. We make them smart by telling them what to do. This is a closer view of that central processing unit or processor. You can see all these basically inputs and outputs of what we have here. There are many inputs and outputs, and an input would be what we tell the computer to do by using a mouse, by typing on the keyboard, or touching the screen. Those are all inputs or some type of input that we can tell the computer what to do. There are lots of other inputs that we can tell the computer what to do with clicks with our mouse. Outputs is what the result we see on our screen. So if we're typing on our keyboard, we see the output of the letters that we're typing. If we tap on a link to go to the internet, we see the output of where that link took us to. If we tap on a computer while tap on our mouse or wiggle our mouse when we're playing a game, we'll see the output of the result of that wiggle or tap on how we're playing that game or the result in that game on the screen. So inputs and outputs are basically what a computer does. It needs inputs from you to make it seem like it's smart to come back out on the screen so you can see what it's doing. Sometimes those inputs are good inputs, right? So we have successful inputs, and then sometimes we have bad inputs because maybe we're stuck in a problem or in a game and it's just not doing what we want it to do. And that's okay. That's a part of the learning process of the different activities you're working on a computer. The inside of the chip contains billions. So if I just open this chip up, it contains billions of wires. And yes, billions of wires. And this is what the inside of that chip looks like. And there's all these are wires and switches that are about 1,000 times smaller than a piece of your hair. Imagine that, 1,000 times smaller than a piece of your hair. So if you see a piece of a hair on your table right now or near your computer, you can pick it up and look at it. Imagine these wires 1,000 times smaller than a piece of your hair. Pretty amazing. Turing Tumble has lots of different activities, and I'm going to stop the video here because I'm having some technical issues. So I'm going to see if this is working, and then I'll continue recording. We're going to talk about the parts for Turing Tumble. And our simulator here, the computer simulator of Turing Tumble, is a little bit different than what we have in the classroom. We have the physical Turing Tumble. So you have a few more options than we have in class, which is kind of interesting, and you can be a little creative, more creative than we can be here in class. So this is the hand tool right here. Hopefully you can see my my mouse, the hand tool, and we'll go over, you'll see me use this hand tool quite a bit. This will place pieces on my Turing Tumble board and flip them. This is the erase tool, which obviously erases our pieces on the board. And then we have our ramp tool, and this is a tool that you'll use probably the most. And this tool will allow the balls to travel down the board to the turnstiles. And I'm just going to place these real quickly here. I'm not going to place all the red ones, but I just wanted you to get an idea of what it looks like. I'm going to use the hand to turn my pieces here so they can go down the ramp correctly. And this one these all need to be turned to that. And then here, this one would need to be turned that way. And then again, I would continue down here in whatever way I wanted to have these ramps go. But for example, if this little arrow here, if you hover over the blue balls, I can press the arrow and the balls will start. This is the turnstile down here. Once the ball hits the turnstile, the blue ball will automatically, this turnstile will release another blue ball. If the red balls are going down here, down whatever pattern I have, and these red balls will go down this final ramp to the red turnstile, it'll release a red ball. So for example, there we go with a blue, and here we go with a red. And as soon as it hits that turnstile, it starts another red or blue ball automatically. So kind of interesting. So you can try to create a pattern. I'm going a red, blue pattern. I don't know if that's going to continue because the blue balls are taking a little longer than the red balls to get down to here. So again, so there we go. My pattern is not complete or correct anymore, but you can see how this works just by this simulation right here. So you can create all kinds of things with these ramps and make these red and blue balls drop down. Once all the balls are at the bottom here, you can press this up arrow and that'll return all the balls back to the top. I'm going to erase some of these. So I'm going to use the erase tool to get rid of some of these right now. There we go. This is the crossover tool. The crossover tool will allow a ball to go in here and cross over to the opposite side. So if this red ball was coming down somehow like this and it entered the crossover tool, the ball would cross over to the other side of that direction. This tool here is called the interceptor tool. So this is interceptor tool. If I had this interceptor tool here and the balls are dropping down, it stops the program. So the balls will stop. It won't hit the turnstile. I'll release one ball here. Let's see if I can do that. Release one ball here and the interceptor would stop. And the program stops. So it's not going to continue because it's not hitting the turnstile. I can release another red ball, and again, nothing's going to happen until that turnstile is, or that interceptor tool is removed out of that area and the balls are allowed to drop. This is the bit. I think it's called the bit. Yes, it's called the bit. And this will actually allow balls to drop either on one side or the other. So the ball would enter the crossover tool, drop here, and it's going to reverse the direction the ball goes. So the ball is coming down here, it's going to drop into here, weigh it down, it's going to flip it to the opposite side when the ball hits that. And then this ball will drop down here, and it's going to go into the bit tool, and it's going to allow it to go to this way instead. So that is called the bit, and you can flip them with your hand or on the simulation with a hand tool to get them to work correctly or start it out correctly, and then it will flip automatically when the balls are going through. This is called the gear bit tool, and this gear bit tool only acts with a gear. Now what happens here is when this gear is turned, you can see these two gear bit tools will turn together the same way. So if a ball enters here, it's going to turn this gear, and both these gear bit tools will turn the opposite direction. So gears is what that's called. We have our balls, and again, you can add more balls if you wanted to. And again, when you go over here, it looks like I'm dropping blue balls, but they actually turn red because I'm on the red side here. There we go. Then we have more drop tools we can add for whatever reason. If you want to add another drop tool, you could to either side. I don't know why you would, but if you want to do some experimenting, you sure could. There we go. I'm not sure why just red balls are going in there, so you would have to experiment to see if you could get blue balls in there. All right, turnstiles. Turnstiles are here, and these turnstiles allow more balls to drop. I guess if you wanted to add more turnstiles, get multiple balls to drop throughout the board, you could experiment with that and kind of have a crazy ball dropping fest, I guess, on your board if you wanted. I'm going to erase some of these things here. There we go. And again, a lot of this is just experimenting. I'll have specific lessons for Turing Tumble, but again, yeah, I'll go ahead and experiment and see what you can come up with. This is the vertical tool. We don't have these tools from here on down on our boards, so this is all just on the simulator. So this will make balls drop down vertically. You can connect 6 of these in a row. So I have, looks like 4 there. Oops. There we go. And I believe you can also, let's see here. I don't think you can turn these. I can erase them, but not turn them. Then I have slope tools. And my slope tools, I can connect together and make them have different slopes. I can have a steeper slope or less of a slope. I can also take my hand tool and flip them the opposite way. Okay, so just depends on what kind of slope you want. And again, I can connect 6 of them together from what I understand. 6 units long is what you can use those slope tools for. And we did an activity using slope last year in our class with tables and marbles. We called it a marble run. So this would be similar to a marble run. So you can make your own marble run just using the slope tools and none of the other tools if you wanted. See how slow you can get your marble, or fast to get your marble to run. This over here, there's lots of things here. So this will, if I click on it, it resets your tool board. Also, it goes back to the regular size board like we have in class. But you can also increase the size of your board by clicking the second one, and a super large board using the third one. So you can make quite a bit bigger Turing Tumble activities than we can create in class, because you can change the size of your board. And this is the largest. Okay, so I'm just going to go back to the regular size that we have in class. This gets rid of all your balls. So the 3 balls with the X's, that gets rid of all your balls. And you can add balls back by clicking on that ball over here and dropping them into each bucket. Again, you can change the colors of your balls, but for whatever reason, I can't figure out how to do that right now. This is to download your creation and save it as a picture. And this is to upload your creation to your computer and save it to your computer. So I'm going to click out of that. This changes your simulation. So if I have my ramp here, this changes just the look of your ramps. They still do the same thing, except for it just changes the look of those ramps. That's all. So I like the original look, so you can see what the actual pieces look like, versus change it to just this type of ramp. Zoom in, zoom out. You can make it small, you can make it pretty big. There we go. And this puts it back to the normal size, which it is already. This is to speed up your simulation or slow it down. If you have an error or you just want to see it in slow motion, you can slow it way down and it'll go really slow. And again, this returns the balls back to the top. These 3 things will take you to websites or GitHub sites. These 2 will, and this will take you to the Turing Tumble site, which we're not going to go to. What I'm going to do now is I'm going to stop the video and I'm going to get the lessons ready for you, put pictures on here, put the pictures on the website so you can see the first 3 lessons and what you have to do. I'll go through the first lesson through you, read through it with you, and I'll do it on the screen here so you can see how the lessons work, and then you can go do the following 2 lessons as well. So there'll be 3 activities for you to do with Turing Tumble. And again, if you do those 3 lessons, you want to just experiment and have some fun and see what Turing Tumble can do. And if you want to try to create a pattern or whatever you want to do with it, you can surely do that. So I will be back in just a bit. Hello, fourth graders. Mr. Wojcik again. Now we're going to go through how the lesson works and what you need to do. Here we go. So the directions are here. Looks a little confusing, but I'll go through it with you. We have the directions at the top. It says scan external challenge number 1, puzzle 1. This is kind of what coding looks like. So they're just trying to make it look like coding. So challenge 1, gravity. Objectives: make all the blue balls and only the blue balls reach the end. And your required output are only the blue balls. So if we scroll down a little bit, you can see my Turing Tumble looks a little bit different than the simulator. So the top looks different, the bottom looks different, the middle is the same. Just know that the simulator of Turing Tumble does the same thing as the one in class. They're just a little different in looks. So your activity is to get all the blue balls down. They started you out with some ramps, and you have to add 4 ramps. They're only letting you add 4 parts. So, okay, I built the setup, and now it looks like I need to figure out where to put these 4 ramps. Oh, I know they need to go here, 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 and here. So let's get the setup done first. So my ramps, so I have one there. I think they had the rest of them going straight down here, just like this. I do have to switch this ramp around, so it drops to here, and now I'm missing a ramp. I'm missing a ramp, so each row needs a ramp. You can't just have the balls free fall to the next piece. So each row needs a ramp. So I'm going to add my 4 ramps. So 1, 2, 3, 4. Notice my ball drops here, goes to this ramp, my ball drops here, goes to this ramp, and then my ball is going to drop here and go straight down. Now, that's not what I need. I need to flip it. So I'm going to flip it just like these 4, so they hit those other ramps. Now it's going to go zigzag back and forth. Okay, so I used 4 more ramps to complete the lesson. And I press the arrow to start, or I could just press this to start my balls to go down. So I'll just press the thing at the bottom there, the turnstile. And there we go. As soon as it hits the turnstile, another ball drops. All right, so there is, I'm only getting blue balls, and it looks like I was successful. All the balls are hitting each row or getting to each row. I'm not free falling any of the balls. And our example of a free fall would be this. So they just kind of just go down randomly, bounce anywhere. That's a free fall. That's not what we want. All right, so I'm going to stop that program, and that is successful. So the next lesson then would be lesson 2. And lesson 2 would look like this. Here, let me bring it up for you. Again, directions are at the top. Scan external, challenge 2, puzzle 1. Challenge number 2, re-entry. Objective is to make all the blue balls and only the blue balls reach the end. Now you can challenge yourself and do something similar with the red balls. See if you can do it opposite. Do the blue balls and then try to do it opposite of the blue balls and do just the red. So on both lessons if you wanted. So again, they didn't give any cartoon or any speech bubble directions here. Some of them will, some of the lessons won't. I'm starting with 8 balls. I have 1, 2, 3, 4, 5, 6 ramps I'm starting with, and I can use up to 5 ramps. Notice I said up to. If you can do it in fewer ramps, great. Do it in fewer ramps. When you're coding, everybody's going to have different solutions to different puzzles, and some codes are going to be longer than the others, but you're going to get the same result. Right? So there is really no wrong answer in coding as long as you get the final result, which would be only the blue balls in this lesson again. So I'm going to set that up. My original setup would be here, and then I have an additional up to 5 ramps that I can use to solve this problem. And again, It's just blue balls. I only want the blue balls. Again, if you want to set it up the opposite way and try to get only red balls after you get all the blue balls, you could try that. All right, so it's just basically the opposite setup as this is right now. And once it hits this lever, it should release another blue ball and all my blue balls should drop down, right? I don't have to do anything. Once I start the program, I don't have to do anything, just like we did here. Oops, just like we did here. Once you start the program, so once I start the program either here or here, it should automatically release the ball again after it hits that turnstile down here, right? So I'm not touching anything, I'm just letting it all happen. And again, you saw that this worked, we're good. And remember, every level needs a ramp. Have fun with it, experiment, and then if you want to do some creative things with it, feel free to be creative, make patterns, see if you can figure out how to add and subtract. That's a little more complicated, but there's lots of fun things you can do with this. I will talk to you soon.